We're going to finish off quadratics by talking about the quadratic formula. Now, before we get into what the quadratic formula is, let's just take a look at this problem to review. So in this example, we have x squared plus x minus 28 equals 0. So normally with a problem like this, we see that there are three terms, and so we automatically think, let's try splitting the middle. So if you're splitting the middle term here, you're trying to find two numbers that are going to multiply to a times c, which is, in this case, negative 28, and add to positive 1. That's your b term. So now you're going to go through your pairs of numbers that are going to multiply to negative 28 and see if you can find a pair that will add to positive 1. So 1 and 28, 2 and 14, 4 and 7. Now it seems like there isn't any pair of numbers that's going to work. So in this case, we would say this is not factorable, and when something's not factorable, that's when you want to use the quadratic formula. So how do we solve using the quadratic formula? So when a quadratic equation cannot be solved by factoring, we have to use the quadratic formula. What is the quadratic formula? That's this formula right here. X equals negative b plus or minus the square root of b squared minus 4ac, that's all under the square root, and then all of that is over 2a. All right, so this formula you need to have memorized. If you don't already have it memorized, you should know it forwards and backwards. You want to make sure that you know what's exactly under the square root, and you want to make sure that everything that you see that's above in the numerator, all of that is in the numerator and it's all over 2a. Now, what are a, b, and c? A, b, and c are given in the quadratic if you write it in standard form, ax squared plus bx plus c. So similar to when we were talking about how to factor, how to split the middle, your a, b, and c are still the same coefficients. All right, so let's take a look at an application of this. So back to that original problem, x squared plus x minus 28 equals 0. How do you go about trying to deal with this? Well, now that we have the quadratic formula, let's write that down first. So I'm going to write down the quadratic formula over here on the side. I need to know what a, b, and c are. So if it's helpful, I would suggest writing down what a equals, b equals, and c equals. In this case, a equals 1, b equals 1, and c equals negative 28. All right, so now we're ready to plug this into the formula. So we have x equals negative 1 plus or minus 1 squared minus 4 times 1 times negative 28, and all of that is over 2 times 1. Now what I'm going to do is I'm going to start with what's under the square root and try to simplify that as much as possible, being really careful with any negative signs. So for example here, when I multiply minus 4 times 1 times negative 28, that's really going to be a positive number after I multiply all those numbers together. So here I'm going to have negative 1 plus or minus the square root of 1 squared plus 112. Adding that together, we end up with 113 under the square root. And then you want to check and ask yourself, can I simplify that radical, that square root of 113, at all? So how do you simplify this? You're checking to see, are there any perfect squares that are factors of 113 that I'm able to take out? In this case, there aren't, so we can just leave our answer as x equals negative 1 plus or minus the square root of 113 over 2. And that's actually our two answers, right? One answer is negative 1 plus square root of 113 over 2, And the second answer is negative 1 minus the square root of 113 over 2. All right, let's take a look at example 2. We have 3x squared minus 5x minus 1 equals 0. All right, you can check and see, am I able to factor this? Well, we're finding two numbers that multiply to negative 3 and add to negative 5. 1 and 3 are the only numbers that will multiply to 3. So those are the only pairs, that's the only pair that we can work with to try to get negative 5. And there's no way for us to get a negative 5 from 1 and 3. So we can jump right into the quadratic formula. Again, let's identify A, B, and C for ourselves. A is 3, B is negative 5, and C is negative 1. Okay, so now let's go ahead and use the quadratic formula. So we have x equals, now be careful here, negative b, so that's going to be a positive 5 plus or minus the square root of, and then when you square that b, make sure you're squaring the entire number. So it's negative 5 in parentheses squared. Minus 4 times a times c, so 4 times 3 times negative 1, and put that all over 2 times a, so 2 times 3. All right, now let's go ahead and simplify. So under the square root, we have negative 5 squared, which once you square it becomes positive 25. And then negative 4 times 3 times negative 1, that's going to give us a positive 12. So we have 25 plus 12 under the square root. All right, we can add that together, and that gives us 5 plus or minus the square root of 37 over 6. And again, double check, look at the radical, 37. Is there any way for us to simplify the square root of 37? So are there any perfect squares that are factors of 37 that I can take out? In this case, no. So we can leave our answer as 5 plus or minus the square root of 37 all over 6. All right, let's take a look at example 3. So same thing, you're always checking to see if you can factor first. But if you can't factor, use the quadratic formula. So you're finding two numbers that are going to multiply to negative 9 and add to 2. So 1 and 9, 3 and 3. Doesn't look like we can do it. So let's use the quadratic formula. All right, so we have x equals negative b. So this is going to be negative 2 plus or minus the square root of b squared, so 2 squared, minus 4 times 1 times negative 9. And we're going to put that all over 2 times 1. All right, again, being very careful with all of our minus and negatives there, we end up with 4 plus 36 inside the square root. And we can simplify that down to the square root of 40. So now we have negative 2 plus or minus the square root of 40 all over 2. Now let's think about whether or not the square root of 40 can be simplified. Well, 4 is a perfect square. That's a factor of 40. So what we can do is we can split up the square root of 40 into the square root of 4 and the square root of 10. And we can simplify the square root of 4, which is 2. So that leaves us with 2 root 10. So instead of writing the square root of 40, we can write this in simplified form as 2 root 10. So we have negative 2 plus or minus 2 root 10 all over 2. Now there's actually one more thing we can do here, which is because both of these terms in the numerator have a 2 in them, and in the denominator we're dividing by 2, we can actually evenly divide both of those terms, and that will leave us with negative 1 plus or minus the square root of 10. And that's going to be our final answer. All right, we're going to do one more example. We have 3x squared minus 2x minus 2 equals 0. Same process. Double check to see if it's factorable. So 3 times negative 2, negative 6. And then b is negative 2. So two numbers that will multiply to negative 6 and add to negative 2. So you're thinking 1 and 6, 2 and 3. it looks like we have to use the quadratic formula. All right, so A in this case is 3, B is -2, and C is -2. All right, so now let's go ahead and plug it right into the formula. So that leaves us with x equals, and again, be careful here with the negatives. Negative b means the opposite of b, in this case is +2, plus or minus, and then b squared, so that's -2 in parentheses, squared, minus 4 times 3 times -2. And we're going to put all of that over 2 times 3. All right, let's look inside the square root first. So -2 squared, once it's squared, becomes +4. And then minus 4 times 3 times -2 is going to give us a positive 24. So we have the square root of 4 plus 24 under the square root. All right, so that's going to simplify down to the square root of 28. And again, now we want to check, can I simplify what's under the radical square root of 28? So are there any perfect squares that are factors of 28? So it looks like 4 would be a factor. So we can rewrite the square root of 28 as the square root of 4 times the square root of 7. So this will simplify down to 2 root 7. So now we have 2 plus or minus 2 root 7 all over 6. And then now we can see if we can simplify this any further. Now because all of these terms, both in the numerator and the denominator, can all be divided by 2, we can go ahead and do that. So that's going to leave us with 2 times 1 plus or minus root 7 in the numerator. It's like factoring out a GCF of 2. And then in the denominator, the 6 can be broken down to 2 times 3. And then the 2 over 2, that's just equal to 1. Those cancel each other out. And that leaves us with x equals 1 plus or minus the square root of 7 over 3. And that is going to be our final answer for this last example.